Machine learning questions that following interviewers really care about. When using convolutional neural network, does max pooling always result in a decrease in parameters? Answer: no, max pooling does not always result in a decrease in parameters. Although max pooling reduces the spatial dimensions of the feature maps, it does not necessarily reduce the number of parameters. The number of parameters remains the same as the number of filters and their weights remain unchanged. However, the spatial dimensions of the feature maps are reduced, which can lead to a reduction in the computational complexity in the number of parameters required to store the output. Weight sharing occurs in which neural network architecture? Answer: weight sharing occurs in convolutional neural networks CNN. In CNNs, the same set of learnable weights is applied to different parts of the input data, which helps to reduce the number of parameters and improve the model's ability to learn spatial hierarchies of features. This is in contrast to fully connected neural networks FCNNs, where each neuron has its own set of weights, and recurrent neural networks RNN, where the same set of weights is applied to sequential data. Therefore, option A, convolutional neural network, is the correct answer. Which strategy does not prevent a model from overfitting to the training data? Answer: data augmentation does not prevent a model from overfitting to the training data. Overfitting occurs when a model becomes too specialized in the training data and fails to generalize well to new unseen data. Data augmentation is a technique that artificially increases the size of the training dataset by applying transformations to the input data such as rotation, flipping, or cropping. While this can help improve the model's performance, it does not inherently prevent overfitting. To prevent overfitting, other strategies such as early stopping, dropout, and pooling are typically used. What are the applications of deep learning? Answer: deep learning has many practical applications in various fields. Some of the most common ones include computer vision, where it is used for image recognition, object detection, and facial recognition. It is also used in natural language processing for tasks like machine translation, sentiment analysis, and chatbots. Additionally, deep learning is used in speech recognition and synthesis, recombinator systems, time series forecasting, and generative models to create new data. These applications have many real-world uses, such as medical image analysis, personalized product recommendations, and predicting future stock prices. Overall, deep learning has the potential to revolutionize many industries and improve our daily lives. What is the main difference between supervised and unsupervised machine learning, and how do you decide which one to use in a particular situation? Answer: supervised learning is a type of machine learning where a model is trained with labeled data, meaning that the correct output is already known for each input. This makes it ideal for tasks like classification and regression, where the goal is to make specific predictions. On the other hand, unsupervised learning is a type of machine learning where a model is trained with unlabeled data and the goal is to discover patterns or relationships in the data. This makes it ideal for tasks like clustering, dimensionality reduction, and anomaly detection, where the goal is to understand the underlying structure of the data. When deciding which one to use, consider whether you have labeled data available and whether you're trying to make specific predictions or understand the underlying structure of the data. If you have labeled data and are trying to make specific predictions, supervised learning is likely a better choice. If you don't have labeled data or are trying to understand the underlying structure of the data, unsupervised learning may be a better fit. Describe the basic components of a convolutional neural network CNN and its applications in image recognition. Answer: a convolutional neural network CNN is composed of three main components: convolutional layers, pooling layers, and fully connected layers. The convolutional layers are responsible for extracting features from the input image, such as edges and lines. The pooling layers reduce the spatial dimensions of the feature maps, reducing the complexity of the data. The fully connected layers are used for classification or regression tasks, taking the output from the convolutional and pooling layers. The combination of these components enables CNN to excel in image recognition tasks, as they can learn spatial features and patterns in images. This makes them particularly useful for applications such as object detection, facial recognition, and image classification. How do you choose the right optimizer for your deep learning model, and what are some common mistakes to avoid? Answer: choosing the right optimizer for your deep learning model involves considering factors such as learning rate adaptability, noise tolerance, and convergence speed. Some popular choices include ADAM, RM SPROP, and SGD. However, common pitfalls to avoid include vanishing gradients, local minima, and overfitting. To choose the right optimizer, you should consider your data, model complexity, and desired training behavior. This will help you select an optimizer that works well for your specific deep learning model and avoids common mistakes. Explain the concept and benefits of regularization techniques like dropout and weight decay and how they combat overfitting. Answer regularization techniques like dropout and weight decay are used to prevent a model from overfitting to the training data. Dropout randomly disables neurons during training, which prevents them from becoming too dependent on each other and makes the model more robust to changes in the input data. This helps the model generalize better to new unseen data. Weight decay, on the other hand, penalizes large weights in the model, encouraging simpler models that are less prone to overfitting. By using both dropout and weight decay, we can improve the model's generalizability and reduce overfitting on limited data. This is especially important when training a model on a small dataset, as it can help prevent the model from memorizing the training data rather than learning generalizable patterns. How do you interpret the results of a deep learning model, and what are the challenges involved in doing so? Answer: to interpret the results of a deep learning model, techniques like saliency maps can be used to highlight the areas that are most influencing the predictions. Additionally, feature importance analysis can be employed to rank the factors that are contributing to the model's decisions. However, there are challenges involved in interpreting the results of a deep learning model, including the fact that the model can be a black box and lack direct explainability. Furthermore, the interpretation often relies on statistical methods which can be complex and difficult to understand. Therefore, it is essential to use multiple techniques and methods to gain a deeper understanding of the model's behavior and decision-making process. Describe the concepts behind generative adversarial networks (GAN) and their applications. Answer: generative adversarial networks (GAN) are a type of deep learning model that consists of two neural networks, a generator and a discriminator. The generator creates new data that is designed to mimic the characteristics of a given dataset, while the discriminator validates the generated data and tries to distinguish it from real data. Through an adversarial competition, both models improve, leading to the generation of realistic images, text, and audio. GAN have many applications, including image and video generation, data augmentation, and style transfer. They are also used in areas such as computer vision, natural language processing, and audio processing. Overall, GAN have the potential to revolutionize the way we generate and manipulate data. What are the different types of activation functions used in neural networks, and what are their characteristics? Answer: activation functions are used in neural networks to introduce nonlinearity into the model, allowing it to learn complex relationships between inputs and outputs. There are several types of activation functions, each with its own characteristics. The most common types are *sigmoid. This function outputs values between 0 and 1, making it suitable for binary classification problems like logistic regression. The sigmoid function is often used in the output layer of a neural network to produce a probability value. *tan. This function outputs values between -1 and 1, making it suitable for problems where the output needs to be centered around 0. Tan is often used in the hidden layers of a neural network to introduce nonlinearity and help the model learn more complex relationships between inputs and outputs. *ReLU rectified linear unit. This function outputs 0 for negative values and the input value for positive values. ReLU is a popular choice for hidden layers because it is computationally efficient and easy to compute. *softmax. This function outputs values between 0 and 1, but is used in the output layer to produce a probability distribution over multiple classes. Softmax is often used in multi-class classification problems. Each activation function has its own strengths and weaknesses, and the choice of activation function depends on the specific problem being solved and the characteristics of the data. By using different activation functions, neural networks can be designed to solve a wide range of problems from binary classification to multi-class classification and regression. What is the main difference between ReLU and leaky ReLU activation functions in a neural network? Answer: the main difference between ReLU rectified linear unit and leaky ReLU is that ReLU sets all negative values to 0, whereas leaky ReLU allows a small fraction of the input value to pass through even when it's negative. This small leak helps to prevent the vanishing gradient problem and can improve the training process. In other words, ReLU is a more aggressive function that cuts off all negative values, while leaky ReLU is a more gentle function that allows some negative values to pass through. This difference can affect the performance and behavior of the neural network. Explain the principles of reinforcement learning and its applications in games and robotics. Answer. Reinforcement learning is a type of machine learning where an agent learns to make decisions by interacting with its environment. The agent receives rewards or penalties for its actions, and its goal is to maximize the rewards. The agent learns by trial and error, and the process is repeated until it finds the optimal policy. This approach is useful for tasks that require exploration, such as playing games or navigating a robot in a new environment. In games, reinforcement learning can be used to train AI players to play games like chess or Go, while in robotics, it can be used to train robots to perform tasks like assembly or navigation. The key principle is that the agent learns to make decisions based on the rewards it receives, which allows it to adapt to new situations and improve its performance over time. What are autoencoders? Explain the different layers of autoencoders and its applications. Answer. An autoencoder is a type of neural network that is trained to copy its input to its output. It consists of three main layers: the encoder, the bottleneck layer, and the decoder. The encoder compresses the input data into a lower dimensional representation, which is then reconstructed by the decoder. The bottleneck layer is the smallest layer in the network where the compressed data is stored. Autoencoders are used for dimensionality reduction, anomaly detection, and generative modeling. They can also be used as a pre-training step for other neural networks. In addition, autoencoders can be used to learn the representation of data, which can be used for other tasks such as classification. The applications of autoencoders include image compression, image generation, and speech recognition. They are widely used in computer vision, natural language processing, and speech processing. Autoencoders are also used in recombinative systems to learn the representation of users and items. They are also used in robotics to learn the representation of robotic arms and their movements. Autoencoders are a powerful tool for learning and representing data, and they have many applications in various fields. What is the main function of an encoder in machine learning? Answer. An encoder is a type of neural network that compresses the input data into a lower dimensional representation, also known as a code. This code is a condensed version of the original data, which can be used for further processing, such as classification or clustering. The encoder's main function is to reduce the dimensionality of the input data, retaining the most important information and discarding the redundant or irrelevant information. This helps to simplify the data and make it more manageable for the model to learn from. What is the primary function of a decoder in a neural network? Answer. A decoder is a neural network component that takes the compressed or encoded data and transforms it back into the original data or similar representation. In other words, it decompresses the code, reversing the process performed by the encoder. This allows the decoder to reconstruct the original data, which can be useful for tasks such as dimensionality reduction, anomaly detection, denoising, and data pre-training. The decoder uses layers like dense, convolutional, etc. to transform the encoded data back into its original form. What do you mean by an epoch in the context of deep learning? Answer. In deep learning, an epoch refers to one complete pass through the entire training dataset. This means that the model sees every single piece of data in the dataset once, and then repeats this process multiple times to learn from it. The more epochs a model goes through, the more it can learn and improve its performance on the task at hand. For example, if you're training a model to recognize images of cats and dogs, one epoch might involve showing the model 10,000 images of cats and dogs, and then repeating that process many times to help the model learn to accurately identify the images. What is the main difference between stochastic gradient descent (SGD) and batch gradient descent (BGD) in machine learning? Answer. Stochastic gradient descent (SGD) is an optimization algorithm that updates the model's weights after each training example, whereas batch gradient descent (BGD) updates the weights after all training examples in a batch. This difference affects the speed, memory requirements, and stability of the algorithm. SGD is faster and requires less memory but is prone to noise and fluctuations, whereas BGD is more stable but slower and requires more memory. This trade-off is crucial in choosing the right optimization algorithm for a specific machine learning problem. What are shallow and deep networks in machine learning, and how do they differ? Answer. In machine learning, shallow networks and deep networks refer to the number of hidden layers and complexity of the models. A shallow network has fewer hidden layers, which makes it simpler and faster to train. However, it may not be able to capture complex relationships in the data. On the other hand, a deep network has more hidden layers, making it more complex and capable of learning complex relationships, but it requires more data and training time. The main difference between the two is that shallow networks are faster and simpler, while deep networks are more powerful but more challenging to train. What are the ethical considerations surrounding deep learning, and how can they be addressed? Answer: deep learning models can inherit biases from the training data, leading to unfair outcomes. This is because the data used to train the models may contain biases such as racial, gender, or age-based discrimination. As a result, the models may learn to make decisions that are unfair or discriminatory. To address these biases, it is essential to use diverse data sets, mitigate algorithmic bias, and promote responsible development practices. This can be achieved by ensuring that the data is representative of the population, using techniques such as data augmentation and regularization to reduce bias, and developing models that are transparent and explainable. Additionally, it is crucial to involve diverse stakeholders in the development process and to conduct thorough testing and evaluation to ensure that the models are fair and unbiased. By taking these steps, we can ensure that deep learning models are developed and used in a responsible and ethical manner. How do you scale deep learning models to handle large datasets? Answer: to scale deep learning models to handle large datasets, there are several techniques that can be used. One approach is batching, where the model is trained on smaller parts of the data at a time. This can be done by dividing the data into smaller chunks and training the model on each chunk separately. Another approach is distributed training, where the model is trained on multiple machines or devices at the same time. This can be done by dividing the data among the machines and training the model on each machine separately. A third approach is model compression, where the model is reduced in size without sacrificing its accuracy. This can be done by removing unnecessary weights or using techniques such as pruning or quantization. The choice of scaling strategy depends on the available resources and the size of the dataset. For example, if the dataset is very large, distributed training may be the best approach. If the dataset is smaller, batching may be sufficient. By choosing the right scaling strategy, deep learning models can be trained efficiently and effectively on large datasets. What is your vision for the future of deep learning, and how do you think it will impact society? Answer: in the future, I envision deep learning continuing to advance in areas like natural language processing, enabling machines to better understand and generate human-like language. This could revolutionize the way we communicate and access information. Additionally, explainable AI will become more prevalent, allowing us to better understand the decisions made by machines and reducing the risk of bias. The democratization of AI tools will also empower individuals and organizations to develop and apply AI solutions, leading to increased innovation and economic growth. However, it's crucial that we also address potential risks, such as job displacement and biased decision-making, through responsible development and regulation. By balancing the benefits and drawbacks, we can harness the power of deep learning to create a more equitable and prosperous society. What is data normalization, and why is it important in machine learning? Answer: data normalization is the process of transforming data into a consistent format to improve the performance of algorithms and models built on it. This is important because it makes features on the same scale, improves training speed and convergence, and prevents features with larger scales from dominating the model. By normalizing the data, we can ensure that all features are treated equally and that the model is not biased towards features with larger ranges. This is crucial in machine learning as it enables us to build more accurate and robust models that can generalize well to new data. Explain the concept of self-attention mechanisms and their role in transformers, highlighting their advantages over RNN and CNN for NLP tasks. Answer: self-attention mechanisms in transformers allow the model to focus on specific parts of the input sequence while processing it, unlike RNN and CNN. This enables the transformer to capture long-range dependencies in text, which is crucial for NLP tasks. Unlike RNN, which process the input sequence sequentially, and CNN, which focus on local patterns, self-attention allows the transformer to attend to any part of the input sequence simultaneously. This parallelization makes the transformer more efficient for long sequences and enables it to perform better on complex NLP tasks. Additionally, self-attention allows the model to weigh the importance of different parts of the input sequence, which helps to capture subtle relationships between words. Overall, self-attention mechanisms in transformers provide a significant advantage over traditional RNN and CNN for NLP tasks. How would you approach the problem of anomaly detection in time series data using deep learning, including specific model architectures and training techniques? Answer: to approach anomaly detection in time series data using deep learning, I would consider using models like long short-term memory LSTM networks or convolutional autoencoders CAE. These models are capable of learning temporal patterns in the data and identifying deviations from normal behavior. For example, LSTMs can learn to recognize patterns in the data by processing sequences of data over time, while CAE can learn to compress the data into a lower dimensional representation, allowing for the detection of anomalies. In terms of training techniques, I would use techniques like backpropagation to train the models and evaluate their performance using metrics like mean absolute error or mean squared error. Additionally, I would consider using anomaly scoring methods such as the reconstruction error to identify the most anomalous data points. However, I would also be aware of potential challenges like handling outliers and concept drifts, which can affect the performance of the models. By carefully selecting the model architecture and training techniques, I believe it is possible to develop a deep learning-based approach to anomaly detection in time series data that is effective and robust. How do you handle the issue of domain adaptation when training a deep learning model on data from a different source than the target domain? Answer: to deal with domain adaptation, you can use techniques like domain adversarial training, where the model is trained to be invariant to the domain features. Another approach is data augmentation with domain-specific features, which helps the model generalize better to the target domain. Additionally, fine-tuning pre-trained models on target domain data can also be effective. However, there are challenges to consider, such as maintaining the knowledge learned from the source domain and avoiding overfitting to the target domain. By using these techniques and being aware of the challenges, you can improve the performance of your deep learning model on the target domain. What is reinforcement learning with deep Q learning (DQN) and how is it applied in robotic control problems, and what are the potential challenges and solutions? Answer: reinforcement learning (RL) with deep Q learning (DQN) is a type of machine learning where an agent learns to take actions in an environment to maximize the reward. DQN uses a neural network to estimate the optimal action value function, known as Q values, which represent the expected return when taking a specific action in a specific state. In robotic control problems, DQN is applied to learn control policies that can adapt to changing environments and tasks. The potential challenges of DQN include delayed rewards, where the reward is received after a delay, which can make it difficult for the agent to learn, the exploration-exploitation trade-off, where the agent must balance exploring new actions and exploiting known actions to maximize the reward, and sample efficiency, where the agent must learn from a limited number of samples. Solutions to these challenges include experience replay, which stores and randomly samples past experiences to improve the stability and efficiency of the learning process, and prioritize experience replay, which prioritizes the most important experiences to learn from. By addressing these challenges, DQN can be effectively applied to robotic control problems to learn control policies that can adapt to changing environments and tasks. How do you approach the problem of explainability in complex deep learning models, especially for critical applications like healthcare or finance? Answer: to approach explainability in complex deep learning models, I use techniques like LLM local interpretable model agnostic explanations, saliency maps, and attention mechanisms. These methods help highlight the model's reasoning by identifying the most important features or inputs that contribute to its predictions. However, each approach has its limitations, and it's crucial to consider context-aware interpretations for critical applications like healthcare or finance, where misinterpretation can have severe consequences. By combining these techniques and considering the context, we can gain a better understanding of how the model is making decisions and improve its trustworthiness. What is federated learning, and how does it enable training of deep learning models on decentralized data without sharing sensitive information? Answer: federated learning is a technique that allows multiple parties to jointly train a machine learning model on their local data without sharing the data itself. This is achieved by having each party train a model on their local data and then sharing the model updates with the other parties, which aggregate the updates to form a global model. This approach ensures that the data remains private and sensitive, while still allowing for the benefits of collaborative learning. The advantages of federated learning include privacy preservation and increased data availability, as parties can contribute their data without sharing it. However, there are also challenges such as communication overhead and non-ID independent, unidentically distributed data distributions, which can affect the performance of the model. Despite these challenges, federated learning has the potential to revolutionize the way we approach data sharing and collaboration in machine learning. How would you design and implement a deep learning model for generative music creation, considering music structure, style, and originality? Answer: to design a deep learning model for generative music creation, I would consider using architectures like autoregressive models or variational autoencoders (VAE). These models can learn to generate music by predicting the next note or melody based on the previous notes or melodies. To control the music structure, style, originality, I would use techniques like conditioning on genre or seed melodies. For example, I could use a VAE to learn a latent space representation of music and then sample from this space to generate new music that is similar to a given style or genre. To avoid repetitiveness, I would use techniques like attention mechanisms or adversarial training to encourage the model to explore different musical ideas. Additionally, I would use metrics like coherence and novelty to evaluate the generated music and adjust the model's parameters accordingly. By combining these techniques, I believe it is possible to design a deep learning model that can generate high-quality, original music that is both coherent and novel. Describe your experience with using deep learning for computer vision tasks beyond image classification, such as object detection or pose estimation. Mention specific models and challenges faced. Answer: I have experience using deep learning for computer vision tasks beyond image classification, such as object detection and pose estimation. One specific model I've worked with is YOLO You Only Look Once, which is a real-time object detection system that can localize and identify objects in images. Another model I've used is AlphaPose, which is a pose estimation model that can detect and track human body parts in images. When working with these models, I faced challenges such as handling occlusions, where objects or body parts are partially or fully hidden from view, and dealing with varying scales, where objects or body parts are at different distances from the camera. Additionally, I've had to consider real-time inference constraints, where the model needs to process images quickly and efficiently. Despite these challenges, these models have shown promising results in detecting and tracking objects and body parts in images. How do you stay current with the latest developments in deep learning, and what are your preferred sources for learning and improving your skills in this field? Answer: to stay up to date with the rapidly evolving field of deep learning, it's essential to show continuous learning and passion for the field. One way to do this is by attending conferences, where you can network with experts and learn about the latest breakthroughs. Reading research papers is another great way to stay informed, as it allows you to dive deeper into specific topics and stay ahead of the curve. Additionally, participating in online communities, such as forums and discussion groups, can provide valuable insights and connections with like-minded individuals. Some specific resources that can help you learn and keep your skills sharp include OurZiv, the DeepMind blog, and online courses. By combining these approaches, you can stay current with the latest developments in deep learning and continue to grow as a professional in the field. What are the ethical implications of deep learning technologies, and how can we ensure responsible development and application of these powerful tools? Answer: deep learning technologies, such as artificial intelligence and machine learning, have the potential to significantly impact society, but they also raise several ethical concerns. One of the main concerns is bias, as algorithms can perpetuate and amplify existing biases in data, leading to unfair outcomes. Another concern is privacy, as deep learning models can learn sensitive information from data and potentially compromise individual privacy. Finally, there is the concern of job displacement, as automation and AI can replace human workers in certain industries. To ensure responsible development and application of these technologies, it is essential to mitigate bias in datasets and algorithms, ensure data privacy, and retrain models for fairness. Additionally, it is crucial to promote transparency and accountability in the development and deployment of deep learning models, as well as to engage in open discussions about the potential societal impacts of these technologies. By taking these steps, we can harness the power of deep learning technologies to benefit society while minimizing their negative consequences. Implement a simple linear regression model from scratch using Python and NumPy. Answer: a simple linear regression model is a linear model that predicts a continuous output variable based on one or more input features. The model is trained using the gradient descent algorithm, which minimizes the cost function mean squared error to find the optimal weights. The cost function is calculated as the average squared difference between the predicted output and the actual output. The weights are updated using the gradient of the cost function with respect to the weights. The gradient is calculated as the dot product of the input features and the error between the predicted output and the actual output. The model is trained by iterating over the training data, updating the weights, and recalculating the cost function until convergence. The final weights are used to make predictions on new data. How do we implement backpropagation in a multi-layer neural network, and what optimization algorithms can be used to update the weights? Answer: to implement backpropagation in a multi-layer neural network, we break down the process into three main steps: forward pass, error calculation, and backward pass. During the forward pass, we compute the output of each layer using the current weights and inputs. In the error calculation step, we calculate the difference between the predicted output and the actual output, which gives us the error. Then, during the backward pass, we use the chain rule of differentiation to compute the gradients of the error with respect to each weight and bias. This allows us to update the weights using optimization algorithms like ADAM or RMSprop. These algorithms adjust the learning rate and momentum to optimize the weight updates, ensuring the network converges to a minimum loss. By repeating this process, we can train the network to make accurate predictions. How can we implement dropout regularization in a neural network model to prevent overfitting during training? Answer: dropout regularization is a technique used to prevent overfitting in neural networks during training. It works by randomly disabling a certain percentage of neurons during training, which helps the network learn to rely less on individual neurons and more on the overall structure of the network. This is achieved by setting a dropout rate, which is a hyperparameter that determines the percentage of neurons to be disabled at each training iteration. By tuning this hyperparameter, we can control the amount of regularization applied to the network, allowing us to balance the trade-off between overfitting and underfitting. In code, this can be implemented using libraries such as TensorFlow or PyTorch, or by writing custom code to randomly sample neurons and set their outputs to 0 during training. By incorporating dropout regularization into our neural network model, we can improve its generalization performance and reduce the risk of overfitting. How can I calculate and visualize saliency maps for a pre-trained image classification model? Answer: to calculate and visualize saliency maps for a pre-trained image classification model, you can use libraries like GradCAM or LIME. GradCAM is a technique that generates saliency maps by computing the gradient of the output with respect to the input image, while LIME is a model-agnostic explanation technique that generates explanations by training a local model on a perturbed version of the input image. Once you have calculated the saliency maps, you can visualize them by overlaying the maps on the original image, which will help you understand which regions of the image are most important for the model's predictions. It's essential to interpret the saliency maps carefully, as they can provide valuable insights into the model's behavior but may also be limited by the assumptions and simplifications made during the calculation process. For instance, saliency maps may not always accurately reflect the true importance of image regions, especially in cases where the model is biased or the data is noisy. Nevertheless, saliency maps can be a powerful tool for understanding and improving the performance of pre-trained image classification models. How can I implement a basic recurrent neural network RNN for text classification, considering the sequential nature of text data and the need to handle variable length sequences? Answer: to implement a basic RNN for text classification, you can start by defining a sequence of word embeddings as input to the RNN. Since text data is sequential, you'll need to use an RNN cell like LSTM or GRU to capture the dependencies between words. To handle variable length sequences, you can use techniques like padding or truncation. Padding involves adding a special token like a zero vector to the end of shorter sequences to make them the same length as the longest sequence. Truncation involves cutting off the longer sequences to make them the same length as the shortest sequence. Once you've processed the input sequence, you can use the output from the RNN to make a classification decision. This can be done by feeding the output into a fully connected layer and applying a softmax activation function to produce a probability distribution over the classes. By training the RNN on a dataset of labeled text, you can learn to classify new text samples based on their content. How do I train a generative adversarial network GAN model to generate new images based on a target dataset? Answer: to train a GAN model for generating new images based on a target dataset, you need to define a generator and a discriminator network. The generator takes a random noise vector as input and produces an image that resembles the target dataset. The discriminator takes an image as input and outputs a probability that the image is real or fake. The generator and discriminator are trained simultaneously, with the generator trying to produce images that can fool the discriminator into thinking they are real and the discriminator trying to correctly classify the images as real or fake. The loss functions for the generator and discriminator are typically the binary cross-entropy loss and the binary cross-entropy loss with the sigmoid activation function, respectively. The training procedure involves alternating between training the generator and discriminator and updating the weights and biases of the networks using backpropagation and stochastic gradient descent. The goal is to converge the generator to produce images that are indistinguishable from the target dataset. You can use libraries like TensorFlow or PyTorch to implement the GAN model and train it. What are some common data augmentation techniques used in image classification training, and how can we implement them dynamically during training? Answer: data augmentation techniques are methods used to artificially increase the size of a training dataset by applying random transformations to the images. This helps to improve the model's ability to generalize to new, unseen data. Some common techniques include random cropping, flipping, and color jittering. Random cropping involves randomly selecting a portion of the image, while flipping involves flipping the image horizontally or vertically. Color jittering involves randomly adjusting the brightness, contrast, and saturation of the image. We can implement these techniques dynamically during training by using libraries such as TensorFlow or PyTorch, which provide functions for applying these transformations to images. For example, in TensorFlow, we can use the TF image random crop function to randomly crop an image and the TF image random flip left-right function to flip an image horizontally. Similarly, in PyTorch, we can use the torch vision transforms random crop function to randomly crop an image and the torch vision transforms random horizontal flip function to flip an image horizontally. By applying these transformations randomly during training, we can increase the diversity of the training data and improve the model's performance. How to debug and troubleshoot common issues encountered in deep learning training. Answer debugging and troubleshooting deep learning models can be a challenging task, but there are some common issues that you should be aware of. One common issue is vanishing gradients, which occurs when the gradients used to update the model's parameters become too small, making it difficult for the model to learn. To diagnose this issue, you can check the gradient values during training and look for a sudden drop-off. To mitigate this issue, you can try using gradient clipping or batch normalization. Another common issue is overfitting, which occurs when the model becomes too specialized to the training data and fails to generalize well to new data. To diagnose this issue, you can monitor the model's performance on the validation set and look for a sudden drop-off. To mitigate this issue, you can try regularization techniques such as dropout alone/Altor regularization. A third common issue is validation training discrepancy, which occurs when the model performs well on the training data but poorly on the validation data. To diagnose this issue, you can compare the model's performance on the training and validation sets and look for a significant difference. To mitigate this issue, you can try data augmentation or ensemble methods. By being aware of these common issues and using strategies for diagnosis and mitigation, you can effectively debug and troubleshoot your deep learning models and improve their performance. What are the key differences between traditional NLP techniques and deep learning-based NLP approaches? When would you prefer one over the other? Answer. Traditional NLP techniques rely on handcrafted features and rules to analyze and process natural language data. On the other hand, deep learning-based NLP approaches learn features directly from the data, using neural networks to identify patterns and relationships. This difference in approach can significantly impact the performance and interpretability of the models. Traditional methods are often faster and more interpretable, making them suitable for smaller datasets or applications where transparency is crucial. In contrast, deep learning-based approaches can excel at complex tasks like sentiment analysis and machine translation, especially when dealing with large datasets. Therefore, the choice between traditional and deep learning-based NLP approaches depends on the specific requirements and goals of the project. What are the main types of neural network architectures used in NLP, and what are their strengths and weaknesses? Answer. Neural network architectures play a crucial role in natural language processing NLP. The main types of architectures used in NLP are recurrent neural networks RNN, convolutional neural networks CNN, and transformers. Each architecture has its unique strengths and weaknesses. Recurrent neural networks RNN are designed to capture sequential information in text. They are particularly effective in handling variable length input sequences, making them suitable for tasks like language modeling and machine translation. However, RNN can be computationally expensive and may suffer from vanishing gradients, which can hinder their performance. Convolutional neural networks CNN are primarily used for identifying local patterns in text. They are effective in capturing features like n-grams and word embeddings, making them suitable for tasks like text classification and sentiment analysis. However, CNN are not designed to handle sequential information and may not perform well on tasks that require long-range dependencies. Transformers, on the other hand, are designed to handle long-range dependencies in sequential data. They are particularly effective in tasks like machine translation and language modeling, where they can efficiently process large datasets. However, transformers can be computationally expensive and may have a potentially black box nature, making it difficult to interpret their results. In summary, each neural network architecture has its unique strengths and weaknesses. RNN are effective in handling sequential information, CNN are effective in identifying local patterns, and transformers are effective in handling long-range dependencies. Understanding the strengths and weaknesses of each architecture is crucial for selecting the appropriate architecture for a specific NLP task. How do you address the challenges of dealing with large and noisy text datasets in NLP applications? Answer: to address the challenges of dealing with large and noisy text datasets in NLP applications, one can use various techniques. First, data cleaning is essential to remove irrelevant or duplicate data. Then, text normalization and tokenization can be applied to convert all text into a standard format. To handle noise, stop word removal, stemming, and lemmatization can be used to reduce the impact of irrelevant words. Pre-processing is crucial for model performance and data quality control, ensuring that the dataset is accurate and reliable for training and testing machine learning models. By using these techniques, NLP applications can effectively handle large and noisy text datasets, leading to better results and improved performance. What are word embeddings, and how do they contribute to deep learning NLP tasks? Can you briefly describe the word Word-2Vec and GloVe approaches? Answer: word embeddings are a way to represent words as vectors in a high-dimensional space, allowing them to capture semantic relationships between words. This concept plays a crucial role in deep learning NLP tasks, as it enables models to better understand the meaning and context of words. By using word embeddings, models can improve their performance and reduce the need for large amounts of training data. Two popular word embedding approaches are Word-2Vec and GloVe. Word-2Vec uses a bag of words approach, where the model predicts the context words given a target word. GloVe, on the other hand, uses a co-occurrence-based approach, where the model predicts the word's context based on its co-occurring words. Both approaches have been shown to be effective in capturing word semantics and improving NLP model performance. How do you evaluate the performance of NLP models for different tasks such as sentiment analysis or machine translation? What are some limitations of traditional metrics like accuracy? Answer: to evaluate the performance of NLP models for different tasks, you need to use task-specific metrics. For example, in machine translation, you can use Blue bilingual evaluation on the study score, which measures the similarity between the machine-translated text and the human-translated text. In sentiment analysis, you can use Font score, which measures the accuracy of the model in classifying text as positive or negative. For summarization tasks, you can use Recall-oriented understudy for gisting evaluation score, which measures the similarity between the generated summary and the human-generated summary. However, traditional metrics like accuracy have some limitations. For instance, in scenarios where there is a class imbalance, accuracy may not be a reliable metric. This is because accuracy is sensitive to the proportion of positive and negative instances in the dataset. In such cases, you may need to use more advanced metrics like BLE-UMINUS4 or Rouge-L, which provide a more comprehensive evaluation of the model's performance. Additionally, you may also need to consider other factors like precision, recall, and Font score to get a more complete picture of the model's performance. What are the challenges of bias and fairness in NLP models, and how can they be mitigated? Answer: NLP models can be biased due to the data they are trained on or the design of the model itself. This can lead to unfair outcomes, such as misclassifying certain groups of people or perpetuating stereotypes. To mitigate these challenges, techniques like using diverse datasets, database algorithms, and monitoring model outputs for fairness concerns can be employed. Additionally, responsible NLP development practices such as transparency and accountability are crucial to ensure that NLP models are fair and unbiased. By addressing these challenges, we can create more accurate and trustworthy NLP models that benefit society as a whole. Can you describe your experience with handling different NLP tasks such as named entity recognition or question answering? Please share a specific project you worked on. Answer: I have extensive experience in handling various NLP tasks, including named entity recognition and question answering. One notable project I worked on was a question answering system that utilized deep learning techniques to identify relevant answers from a large corpus of text. The system was designed to handle complex queries and return accurate responses. I was responsible for developing the model, training it on a large dataset, and fine-tuning it to improve its performance. The project allowed me to apply my knowledge of deep learning and NLP to a real-world problem, and I was able to overcome several challenges, including handling out-of-vocabulary words and dealing with ambiguity in the input queries. The project demonstrated my ability to apply theoretical knowledge to practical problems and my capacity for problem solving.